So let's talk a little bit about antenna innovation, right? So one of the things that we like to do is try to continue to innovate on our products, what we can do, how we can improve it, how we can make it better, how can we come out with something that's not in the marketplace. Sometimes, you know, all of the main manufacturers, as far as the radio providers, they do have their own antennas. We provide equivalents of those antennas, but we also come up with antennas that cover a niche that they typically don't cover with their antenna product lines, or an aesthetically pleasing solution that they don't have in their antenna line. So we come up with these products, and I want to go over a couple of them with you. So this is our raised access floor Wi-Fi antenna, and a lot of you may know about this antenna. We actually took a raised floor panel, concrete floor panel, and we etched it out and we embedded one of our antennas into that raised access floor panel. We've deployed this in a lot of Fortune, let's say Fortune 10 companies with great success. It's on the floor, so now you have a bottom-up approach as far as radiation compared to a top-down approach of ceiling-mounted antennas. And some of those benefits I have here as far as aesthetics, you don't have an AP mounted on the wall or ceiling. The installation is easier and less expensive because you're just pulling cable along the floor. You don't have to pull it up the wall and over and behind the ceiling, or need a forklift or someone to do those types of things, because all of this, everything is under the floor. For upgrades, support and maintenance, reconfiguring is easy and it's scalable. And then also, we went and tested it for loading, for floor loads with the Ceiling and Interior Systems Construction Association. So this has the same load characteristics as a standard floor panel without an antenna embedded into it. So for continuing innovation, so the first design that we came out with was a 4-port design, as you can see by the pictures to the right, showing how it's manufactured. But now we're working on a 6-lead. We have a 6-lead design for RPSMA. We have an 8-lead design that we're currently working on for RPSMA, and a DART-enabled 8-lead design. Then we also have a directional antenna design for 6 leads. And we're working on the Wi-Fi 6E design, which I want to go over real quick, and then a wall mount version that I'll discuss. When we first came out with this antenna, we had an agreement with one of the major flooring manufacturers in the US. So they had an exclusive agreement with that. Now that that exclusive agreement is up, we're working with all of the floor tile manufacturers now. So it's expanded the ability to do this design for different manufacturers. So how did we take this design in broadband? And so this is the actual pattern of the design. The large disc that you see is the 2.4 design, with the smaller disc is the 5 gig designs. So we optimized the low band and the high band separately. Then we optimized the low band and the high band filter section. So we want to intertwine the two to optimize depending on the frequencies. Then we optimized the low band radiator with the high band filter for minimum visual and low band and maximum reflections at high band, and then vice versa with the high band. Then we combine all circuit together and run a sensitivity analysis. So once everything's together, you want to see how everything plays together. So by running a sensitivity analysis, we could see what parameters affect visual and gain. So those were the 2 parameters that we wanted to design for and optimize. And then we ran parameter iteration to minimize visual at low band and high band and maximize the gain. So you want a balance of low visual but high gain. So that's that visual is set at 2-to-1, and at 2-to-1, that's telling you that 90% of your power is going out of your antenna and only 10% is being reflected back to the antenna. So that's what we set as the specification to design for. And then we ran a final optimized geometry to obtain the antenna performance. Now, as you can see from this picture to the right, This is a 6-lead design or a 6-port design. When we go through this analysis of broadband, and we start with just one of those antennas. And then once we get that, we replicate it, and then we play with the space in between them to optimize the performance as far as no shadowing or anything like that between each antenna. So this is the final geometry that we come up with for the antenna.
Dennis, can I jump in there real quick? I had a brief interruption, and I might have missed this. It looks like everything here is polarized in the same direction. Is that is there no gain or no improvement, I should say, by cross-polarizing these?
So so there could be, but just for the design for this one, we kept it all vertically polarized. And because since this is a floor design, you're going to get a lot of reflections and everything off the furniture and everything there. So I think we can achieve the same thing as the cross polarization just because of the reflections that you're going to see.
Gotcha. Okay. Yes. Thank you.
Good question, but thanks, JD. So now that we had the floor design, it was like, okay, we had some customers that actually want to put this in the wall, but you can't take a concrete slab and place it into the wall, right? So we wanted to come up with a design that was actually that we could mount within the wall. And there's our customer specification is that they want to put it behind the sheetrock, and they want to be able to put it between the wall studs. So we came up with a similar design, but instead of the concrete tile, we used high density polyethylene as the block, and then a dowel ring cover to fine tune it for the resonant frequency. This is adjustable and with slot rails so that it can fit between different wall stud sizes. It's easily removable, and we have a 4-lead version, and we're currently working on the 6-lead version. Just a quick note, this is one of the actual designs. As you can see, there's an arrow on there. The arrow shows you the direction that you want to mount it to maximize maximize the pattern of the antenna. So you set it based on the direction of the antenna if you want to maximize the radiation characteristics. That's the direction that you want to mount the antenna. Wherever you want to maximize it, that's where you point that arrow or mount it based on that arrow.
So, Daryl, quick question on, or Dennis, I'm sorry. Quick question on that. Is there some way with that to mount an AP to the back of that antenna, with it being in a wall? Obviously, not easy to get an AP there.
So, yeah, so we're looking into some mounting solutions to do such. I know for the floor, when we came up with a solution that mounted it to the standoff, so we're to the standoff or the pedestals under the floor. So we're actually looking at mounting solutions to mount it behind the actual panel as well right now.
What type of coax are you using between it, especially if you're going to put an AP or the antenna in the wall and maybe an AP above it? You would have to use a very low loss cable so you don't get so much attenuation.
Yes, it's a low loss plenum cable. So we use a low loss plenum cable.
LMR?
Yes, or our equivalent, which is TWS. So we have an equivalent of the LMR cable.
And what's the length on the coax?
So the length on these coax, these are 3-foot cables. So if you want to get it up above, you would have to use a low loss jumper. So right here is our junction box antenna. This is a patented antenna from Ventev. And what we did is we took a 3-gang junction box and we embedded a 6 dBi directional antenna into the junction box. It has 4 leads coming out the side. And from this picture, that arc that you see with the screw, that's how you articulate the antenna. So you have 40 to 45 degrees of articulation with this antenna. So depending if it's if you mount it up high and you need to articulate down, you just move that and tighten it to the articulation point you want. And if it's low and you want to go high, you rotate that antenna 180 degrees so that the cable is on the opposite side, and now the articulation is going from the bottom up. So we've had great success with this, but one of the questions that we had with this antenna is, once I get it in the wall, I want to be able to articulate it. I don't want to articulate it and then place it in the wall. So what can we do? What can you do about that? This just shows some deployments of the actual junction box. The middle one is at a university in one of the classrooms, so it's just on a hard cap ceiling, so that the performance just is straight down, no articulation right there. So how did we make it articulate? So we added front articulation to the junction box, and how we did that was on the back of the ground plate behind the antenna. The antenna is on standoffs from the ground plate. On the back of that antenna is a spring-loaded system, so that anytime you move it in the 10 degrees increments, it's set based on the strength of that spring, and it doesn't move. So you actually can move it. This one has 40 degrees of articulation, so you can articulate it from the front. So once it's in the wall, you can adjust the antenna by we have a set screw down the bottom with a tab on it that you can pull. This is one of the mock-up models that we have, and as you can see, you have the 10-degree lines on it, but you'll have a tab down at the bottom that you can pull and articulate it in 10-degree increments. And once it's set there, it's sturdy. It won't move unless you physically move it. And then we came up with an omnidirectional antenna in the junction box. So this will not have any articulation. It's a bent dipole design. By bending the dipole, you're able to get omnidirectionality out of the antenna. So this is a bent dipole design, no articulation, and this is a 4-port Omni. Now this will be placed up on the ceiling or hard cap ceiling with no articulation if you want a aesthetically pleasing Omni fit. And we're producing this for some universities that's looking to provide that type of coverage in some of their lecture halls.
Dennis, on that, so I'm assuming that's kind of flush mount.
Yes.
Are you not getting quite a bit of dB loss kind of around the edges due to absorption into the sheetrock? How are you kind of addressing that?
So with the sheetrock, you will encounter some loss, but in our testing, we didn't see any major loss. And then plus all of the plastics around it, there's minimum loss through the plastic. The omnidirectionality and then the vertical as far as the beam width on the vertical side isn't as wide to get interference, say, from the sheetrock. So it's more the omnidirectional pattern. But this gives you like, it's not a full Omni, it's pseudo Omni, and you actually get a X and a Y component to the E plane, so you get coverage.
Okay.
So our next innovation that we're working on is what I call plug and play antennas. So imagine you're a Wi-Fi provider and you put up antennas and access points, and now it's time to change, or there's a new Wi-Fi access point that you want to put up, and it's no longer a 4-lead or a 6-lead, and but you have antennas and you want to reuse the antennas. So this plug and play antenna starts out with a maximum of 6 ports on the antenna. But what happens is we have the cables that actually snap into the antenna. So if it's a 6-lead AP, you plug in 6 cables. If it's a 4-port AP, you plug in 4. If it's a 5-port AP, you plug in 5. So the genesis of this actually came from the from the Meraki radios, the MR, I think the 43 that has the 5 ports on it. And we were always being asked for antennas for that radio, and we didn't have any 5-port antennas. So it's like, okay, we can do a 6-port antenna and just not connect one of the ports. But we've eventually come out with 5-port antennas. But the genesis of this idea was based on that. I was like, so how can we come up with something where we just plug in the number of antenna leads that you need based on the ports of the radio? So we came up with this design. So you plug in the antennas, and once they're in, these are MCX connectors. Once it's in, it's pretty much stable. It snaps in, so it's not going to come off unless you purposely try to pull it off to get it off, or to get it disconnected. So we have those, and this is a design that you guys will be seeing probably in the next quarter or two. This is a directional that we have. This antenna actually is, if I was to equivalent this to something, this would be like a 6-lead Cisco P4W. 115, 105 degree beam width on the horizontal, and 60 to 65 degree beam width in the vertical plane.
So Dennis, if the intention here is to use whatever number of elements you want for your particular design, I imagine the per element RF shape is going to be really super important depending on your design.
Yes.
Is your data sheet going to have like each individual element's coverage pattern laid out so you know exactly what you're going to get with whatever combination you use?
And we can provide that. And one of the things, as far as bringing this to market, one of the things that we'll concentrate on is making those patterns consistent over each port, so that when provided, even if you do pull a certain one out, then the pattern should be the same. And also, the main thing about that, we're pulling them out, you want enough isolation between the antennas such that there's no interference of having just the open port there and a signal jumping onto that port. So we'll make sure that from an isolation perspective, as well as a consistency perspective across the antenna performance over the frequencies, that is consistent.
Dennis, is there some physical thing that you're doing to perhaps block that port when it's unhooked so it doesn't have any kind of radiation?
No, there's other than making the isolation, the port-to-port isolation between the two high enough, and in this case, low enough, so that signal would be so low that it wouldn't interfere with the signal of the antenna that's actually being connected to the radio. But one of the things that we could do as an aside is provide 50 ohm loads that you just snap into the ports that you're not using. And the 50 ohm load pretty much just shortens the antenna.
So I think we've got a couple of questions. It looks like there was one from Twitter from our friend Jim Palmer.
Okay.
Can the MCX connector be cross-threaded? I know it snaps in, but installers are great at breaking things.
Yes, we can look into that. We just started off with the MCX. I'm actually looking to see if I can get a larger. I'm looking into a larger type of a connector as well. With those MCXs, you know, you got the little, you have the center pin and it snaps in. But if someone's heavy-handed, they could easily not line them up. So we're looking into that as well. And we're also looking into some things with the RPTNC and RPSMA connectors to make those swappable as well. But that's still in the research phase.
Okay, thank you.
Hey, Dennis, quick question.
Yes.
I want to go back to the warehouse antennas and the 13 dBi gain.
Mm-hmm.
Is there a compatibility matrix listed somewhere for customers, for end users that would, may otherwise break EIRP limits if those antennas are connected to, we'll use in this case, a Cisco 3802E versus a Cisco 3802P?
Right. So yes, there is. So there's a set FCC limit of maximum power out. So based on the antenna, you dial back the transmit power on the AP so that it meets that. I think it's 33 dBm total EIRP. So depending on the antenna gain, you dial back the power out of the radio. If it's not, like you said, a P model, which is standardized on a 13 dBi antenna from Cisco. Did that answer your question? I'm sorry, Jason.
Yes, thank you.
Okay. I was waiting for a nod or something from you, so I apologize. So the last antenna that I wanted to go over with you guys is a LTE LAA antenna that we designed. We worked in conjunction with AT&T, and this antenna is actually deployed at Gillette Stadium in Boston, home of the New England Patriots, right? So, so we do some carrier type antenna designs as well. And I just wanted to highlight the availability of this, a 2-port high gain design covering licensed and unlicensed, PEM rated, DC grounded, and a ruggedized radome. And these are paintable radomes. So as you can see at the stadium, they painted them blue. So I just wanted to highlight something as far as another type of solution outside of Wi-Fi that we actually work on producing as well.